6.1, number 10. Supposed to find the area between these two curves and the y-axis. So let's make a sketch of this. E to the x will go this way, going through 1 on the y-axis. 12 minus e to the x. Minus e to the x would look like this, flipped over the x-axis, and then up 12, so it'd be up here at 12 someplace coming down where it crosses at 12. And they're going to intersect out here someplace where 12 minus e to the x equals e to the x. And so if I solve this by adding e to the x to both sides, I get 12 equals 2e to the x, adding e to the x to both sides, divided by 2, and I get e to the x equals 6. So x equals ln 6. So they meet at ln 6, and the height would be, when I put ln 6 in here, e to the ln 6 is 6. E to the ln 6 equals 6. So the intersection point is ln 6 comma 6. Now, if I want to find the area between the curves, I can take this one minus this one from 0 to ln 6, or I could take the area under this curve going horizontally, and then the area here horizontally, or just this one and double it. So got a couple ways to do it. So let's see. Let's set up both of them here. If I wanted to go this way, it would be the integral of the top curve, which is 12 minus e to the x minus, that would give me all the area all the way down. Then subtract the area under e to the x, and I'd be integrating from 0 to ln 6. This would be integral from 0 to ln 6 of 12 minus 2e to the x dx, which would be 12x minus 2e to the x, evaluated from 0 to ln 6, which would be 12 ln 6 minus ln 6 in here is 6 times 2 is minus 12. I put 0 and I get 0, put in 0 here and I get e to the 0 is 1 times negative 2 is negative 2, and I'm subtracting a negative 2, so it's plus 2, which would be 12 ln 6 minus 10. Now, if we go the other direction, then we'd have the integral from 1 to 6, and I would just have from here to there, so I'd have to solve this curve for y, which would be ln y is what x is. This, if I solve for x, it's ln y, dy. However, the integral of ln y is something we haven't quite figured out yet how to do. So probably don't want to do sideways on that one. And we'd have to double this answer to get this. Now let's just kind of check ourselves, though. We can do this on the calculator. Let's calculate this one. 12 ln 6 close parenthesis minus 10. And then let's check this one. Let's go to y equals, ignore my messes here and come down to this one, and we'll put in 12 minus 2 e to the x. Whoop, don't need a parenthesis on that. And then I'm going to integrate that from 0 to ln 6. Second, calculate the integral of that from 0 to ln 6. I get 11.5 something, which is what I got here, 11.5 something. Now, what if I do it the other direction? So come down to here, and I'll clear that one, and I'll put in the other question as ln x. And I'm integrating ln x from 1 to 6 and times 2. So I can just say times 2, and then I can go second calculate as 7, and I'm going from 1 to 6. Lower bound 1, enter, 6 is the upper, and I get the 11.511 again. So I can do this one with the calculator. We haven't figured out how to do it with calculus yet. 18. Since these line up, and see, where do they intersect at? So we have 1/2 x equals x square root of 1 minus x squared. So if I divide both sides by x, I get 1/2 equals square root of 1 minus x squared. If I square both sides, I get 1/4 equals 1 minus x squared. Add x squared, subtract a fourth, and I get x squared equals 3/4. Take the square root, and I get x equals plus or minus the square root of 3 over 2. That's how far out the x's are. Square root of 3 over 2. So I want to integrate. The top function would be this one, which is x square root of 1 minus x squared from 0 to square root of 3 over 2 minus the other one. I could actually just figure this triangle out, but I'll do the integral anyway. 0 to square root of 3 over 2 of 1/2 x dx. This will give me the area of the triangle. This will give me the area of all the area under this curve. And I need to double that for my answer. So this one, if I let u equal 1 minus x squared, du would equal minus 2x dx. And so du over minus 2x is dx. So this integral would become from something to something, x square root u du over minus 2x. X's cancel. The integral of square root of u, that's u to the 1/2, so I add what's 3/2, so it's 2/3 u to the 3/2 with a minus 2 in the denominator. So those 2's will cancel, and I'm going to evaluate that from something to something, but if I change it back, it would be minus 1/3. Let's see, my u was 1 minus x squared to the 3 halves, evaluated from 0 to the square root of 3 over 2. So square root of 3 over 2 squared is 3/4. 1 minus 3/4 is 1/4. Square root of 1/4 is 1/2. Cubed is 1/8. Times negative 1/3 is negative 1/24. Plus, put in 0. 0 squared is 0. 1 minus 0 is 0. The square root of 1 is 1. 1 square root of 1 is 1. Cubed is 1. So the minus a minus 1/3. So this becomes 1/24 minus 1/24 plus 1/3. So I multiply by 8 and 8. And so that's 8/24 minus 1/24, 7/24. So the area under all of this is 7/24 for this part. And then I have to subtract this area, which is this. The integral of that is going to be 1/4 x squared evaluated from 0 to square root of 3 over 2. Square root of 3 over 2 squared is 3/4 times 1/4 is 3/16 minus 0. So the area down here is 3/16. So I have 7/24 minus 3/16. See, what do these both go into? 48. So this would be 14/48 minus 3, 9/48, which is 5/48. That would be this area, and then I have to double it. So 10/48, which is 5/24. Okay, this one. So this area matches this area. And then I have all of this, which is this area matches that area. And then from here to here, this one is all below this one. So I could just do from this one minus that one for that whole last area. So I'm going to have, see, this curve is above for all of that. So I could go from here to here to get this and this. And then I can get this for that same curve minus that. And then for this one, I have to switch them. So I'd have the integral, let's just start from here. This one is the cosine 2x minus sine x. And I want to integrate that from 0 to pi over 6 to get that area. And then I'll integrate it again from 5 pi over 6 clear out to 2 pi to get this area. And then I need to do also an integral from pi over 6 to 5 pi over 6 of the reverse of this, sine x minus cosine 2x dx. Okay, so let's integrate this. This would be cosine of 2x, derivative of sine is cosine, so it'd be sine of 2x, but then the chain rule would say then times a 2. We don't have that, so we'll have to divide by 2. So that's the integral of cosine 2x. The integral of minus sine x is plus cosine x. We have to evaluate that from 0 to pi over 6, and again from 5 pi over 6 to 2 pi. And then we have to integrate this one, which is going to be just the negative of these two, or turned around. So it's going to be negative sine of 2x over 2 minus cosine x, evaluated from pi over 6 to 5 pi over 6. So we're putting all pretty much the same numbers in here. So let's see what we get. Pi over 6 times 2 is pi over 3. Pi over 3, the sine is square root of 3 over 2 over 2, plus the cosine of pi over 6 is the square root of 3 over 2, minus, put 0 in there, sine of 0 is 0 over 2 is 0, and the cosine of 0 is 1. For this one, 2 pi times 2 is 4 pi, sine of 4 pi is 0, plus cosine of 2 pi is 1, minus 5 pi over 6 times 2 is 10 pi over 6, which is 5 pi over 3. 5 pi over 3 is 1, 2, 3, 4, 5. The sine is negative square root of 3 over 2 over 2. And the cosine there is 1/2 plus 1/2. And then finally, we got to do the negative of 5 pi over 6 put into here. Well, that's what this is, because we did this and subtracted, so it's negative. So it's going to be exactly this. Negative of that is square root of 3 over 2 over 2 minus 1/2. Then pi over 6 in here, we did that up here, and we got this, but we have to do the negative of that, which is minus, minus pi over 6 into here was this, the square root of 3 over 2 over 2 plus square root of 3 over 2. And the minus, and we're supposed to subtract, and we're doing the minus of all this, so this becomes a plus. There we go. So we need to add all of this together. So this is a minus 1, this is a plus 1. They cancel. This is a square root of 3 over 2 over 2. This is another one, so that's just a square root of 3 over 2. This is another square root of 3 over 2, and this is another square root of 3 over 2. So we've got 1, 2, 3, 4 halves, which is 2 square root of 3, so it's just the square root of 3. Because square root of 3 over 2 over 2 is the square root of 3 over 4. We have that 1. This is plus 2, 3, 4. So that's the square root of 3. That takes care of those. And then we have the square root of 3 over 2. plus another square root of 3 over 2, so that's another square root of 3. And then we have minus a half and minus another half minus 1. Okay, 21. So this one would probably be better to do this minus the area under this curve, which would be to the axis. And that curve is this one, so we'd find the integral from 0 to where they intersect. And do they actually give, I think they give you that in the book, but maybe they don't. Let's see, we'd have to find that. So that'd be 1 minus cosine y equals sine y. 1 is 1 minus the cosine equal to the sine. The sine cosine would have to be the same. Sine y plus cosine y equals 1. When would that add up to be 1? Let's see if they give us that intersection point. That one's not obvious to me. Just thinking here, so let me look at it. Page. Get to the right page here. Oop, that's the second. Pi over 2. Let's see. At pi over 2, the sine is 1 and the cosine is 0, so 1 minus 0 would equal 1. So yeah, at pi over 2. This is pi over 2. Yeah, that should have been obvious, and I didn't catch it. So we're going to integrate from 0 to pi over 2 of the top curve, which is this one, which is sine y, minus the bottom curve, minus the area under this curve, which would be 1 minus cosine y. So the integral of sine is negative cosine y. The integral of negative 1 is minus y. And the integral of plus cosine y is plus sine y. Derivative of sine is cosine. Derivative of negative cosine is positive sine. Evaluate from 0 to pi over 2. Cosine of pi over 2 is 0 minus pi over 2. Sine of pi over 2 is 1 plus 1 minus, and we put in 0. Cosine of 0 is 1, so minus 1, 0, and sine of 0 is 0. So we have minus pi over 2 plus 1 plus 1 plus 2. And that would be the area there. Now we have this one, and they both cross here on the x-axis. One has x-intercept of 10, one has x-intercept of 40. So this one must go to this curve. So from negative 5 to negative 1, the curve that's on top is not this one. The one that's farthest away from the axis is this one. So we're going to have y cubed minus 26y plus 10 minus the one on the bottom, which is this one or this one. So 40 minus 6y squared minus y cubed for this part. And then we're going to swap these two, or just take the negative of this when we evaluate from minus 1 to 3. So, can we simplify this? So we've got minus 5 to 1 of y cubed minus y cubed. That's 2y cubed. And then we got minus 26y, no other y's, minus 26y. We have plus 6y squared. And then we have 10 minus 40, which is minus 30. Okay. So this would be y to the fourth over 4. 2 over 4 is 1/2, so that'd be y to the fourth over 2. This one would be divided by 3, so we'd have plus 2y to the third. This one we divided by 2, so we have minus 13y minus 30, y squared, minus 30y. Evaluated from minus 5 to 1, and then the opposite of this, evaluated from minus 1 to 3. So if I put 1 in here, I get 1/2 plus 2 minus 13 minus 30. Oh, that's supposed to be minus 1. Oop, better be careful here. Minus 5 to minus 1. Missed that. So minus 1 in there is still plus 1/2. This would be minus 2. This would stay plus 13. This would stay changed to plus 30. There we go. Then put in minus 5, and I get a ugly 525, 625 over 2. 125 times 2 is 250 plus, no, minus 250. Oh, 25 times 13. That would be minus 25 times 13. $325 minus $325 plus $150 for that one. And then get that answer, and then I have to do this one, which would be 81 over 2. And we have to take the negative of all this. And this would be 54. And 9 times 13. 130 minus 13. 117. 1 minus 117. minus 90. And this minus is times all this, so I got to put another parenthesis here, then minus. And then I got to put in minus 1, which is into this same thing. So it's 1/2 minus 2 minus 13 plus 30. And if I take the negative of all this and that and add them up, I should get the areas between those two. Yuck. But I'm not going to do it. I'll let you do that. Okay, now we got to find the area bounded by this. So I'm going to have to draw a graph. So this one goes through plus 4. It has a y-intercept of 4 and an x-intercept of 4. This is y equals x, so that goes like this. And this one is y equals minus 3x plus 4. So it goes through here, and a slope of minus 3, so it hits right there. So this is the area bounded by that. So if I went vertically, I'm going to have to do this one minus this one until we get to 1, from 0 to 1, and then this one minus this one from 1 to 2, which is where they meet. Or if I go this way, I'm going to have to do this one minus this one from 2 to 4, and from 1 to 2, I'm going to have to do this one minus this one. So I'm going to have to do 2 either way. So I'm just going to do vertically. So I'm going to go integral the first section. I'm going to take this curve, which is y equals 4 minus x. That's this one minus this one. That's the lower bound for this first part, and that one's the minus 3x plus 4. So I took the top one minus the bottom one to get this one from 0 to 1 in the x direction, plus from 1 to 2, it's going to be the same top one, minus this one, which is y equals x. Now some people take and do this one from 0 to 2 to find all of this area, and then subtract the area under this one, and then subtract the area under this one for the two pieces. And you can do it that way also. I'm putting them together like this, so this would be 0 to 1 of 4 minus 4. The 4's cancel, and I've got minus x plus 3x, which is 2x. That one's going to be easy to do. Plus integral from 1 to 2 of 4 minus x, which is 4 minus 2x. That one should be easy to do. This is x squared evaluated from 0 to 1 plus 4x minus x squared evaluated from 1 to 2. So that's 1 minus 0 for this one, plus 8 minus 4 minus 4 minus 1. So that is 1 plus 4. 4 minus 1 is 3 minus 3. So I got 5 minus 3, which is 2. Okay. 37. X equals absolute value of y equals absolute value of x looks like this. So x equal absolute value of y would look like this, not a function. And x equal minus the absolute value of y would be this way, with a plus 1 would move it over 1. So, since this is so symmetric, it's a square, this would be pretty easy to do. We'll just figure out the area here. And that's pretty easy to do. That'll be the integral from 0 to 1/2 of x dx. Or we can do the other way direction, but that's all we have to do, which is going to be x squared over 2 evaluated from 0 to 1/2. Putting in 1/2 in there, and we get 1/4 divided by 2, which is 1/8. The area, that's 1/8, and we need 4 of them, so 4/8, which is 1/2. Now, they were hoping you would do something like this part or this part. Let's see what the equation of that would be. That would be, if we're doing it this way, it'd be x equals 1 minus y, I believe. So when y is 0, we'd have 1, and when y is 1, x is 0. When y is 0, x would be 1. So that matches this line. And then this one is y equals x, or x equals y. And so the top curve for this, just doing that part, the top curve would be this one, or the right-hand curve, and then the left-hand curve is this one. So if we integrate from 0 to 1/2, actually this is plus 1. So from 0 to 1/2 of the top curve, which is this one, minus the bottom curve, which is this one, in the y direction, then we'd get 1 minus 2y integrated be y minus y squared, evaluated from 0 to 1/2. So that would be 1/2. In there would be minus 1/4. And then putting in 0, we get 0. So 1/2 minus 1/4 is 1/4. That would be this, and then we'd have to double it. So 1/4 times 2 is 1/2. Okay. X equals 2y. Okay, so that looks something like that. So when x is 2, y is 1. If you want, you can divide by that and you see it's a slope of 1/2 line. And then this is a parabola. If we subtract 1 from both sides, we get x equals y minus 1 squared minus 1. So y minus 1 means it's moved plus 1 in the y, and then taken minus 1. So it'd be a parabola that's something like this. And we're supposed to find the area inside that. So, where do they intersect? Okay, so I think they intersect at 0, 0. If I put 0 in, that works in here, and 0 in here, I get minus 1 squared and 1. So that they meet at 0, 0. And they also intersect at what? 4 in the x and 2 in the y. Is that right? It works there. 4 in the x would be 5. And 2 minus 1, no, that doesn't work. Okay, so where do they intersect up here? So we'd have to set 2y equal to this. Y minus 1 squared minus 1 equals 2y, because we want to know where they meet here. So this would be y squared minus 2y plus 1 minus 1 equals 2y. So we'd have y squared minus, subtract the 2y over, so that'd be minus 4y, and these cancel. So y equals 0 or 4, because this factors to y times y minus 4. So 4. 4 in the y, so that's going to be out there pretty far. 8 in the x. 8, 4. So sideways works best on this, so we'll take the integral from this curve's always the farthest to the right, so that's going to be the top one, which is 2y minus the 1 underneath, which is this one, y minus 1 squared minus 1. And we're going to integrate from 0 to 4. So let's simplify this. So this would be y squared minus 2y plus 1 minus 1. And then we'd have 2y minus this. So we're going to have 2y minus a minus, so that's plus 2y, so that's 4y minus y squared dy. Integrating that, that would be 2y squared minus y to the third over 3 from 0 to 4. So we get 16 times 2 is 32 minus 64 over 3. Putting in zeros, we get 0. So if I multiply this by 3, I get 96 thirds minus 64 thirds, which is 32 thirds, or 10 2/3. X equals sign y. So this is x and this is y. So this is the positive direction. So the sign starts at 0. It would go to plus 1 to minus 1. We'll be doing that. And x equals, so this would be pi over 2x equals y. So we have to go to a slope of up half a pi as x goes over 1. So they intersect right there. And so if we go sideways, like this is kind of indicating, because it's got x all 4, the rightmost curve is the sine y minus the 2 over pi y integrated from 0 to pi over 2. That's where they're going to run into each other. believe that's right. Sine of pi over 2 is 1, and 2 over pi times pi over 2 is 1. Yes. So the integral of sine is negative cosine y. Integral of this would be minus 1 over pi y squared. Evaluate from 0 to pi over 2. Cosine of pi over 2 is 0. And pi over 2 squared is pi squared over 4 times 1 over pi. And so that's going to be minus. One of the pi's will cancel, and I'll get pi over 4. Minus, and if I put 0 in there, cosine of 0 is 1, so I get a minus 1 minus 0. So I get minus pi over 4 plus 1.